Astronauts and cosmonauts, we've seen them train and study for years to enable these select people to work and live aboard the International Space Station. We have seen countless hours of their activities live on television and in the media. With this wealth of experience and insight behind them, what do they think when they return to Earth? Without exception, these spacefarers simply cannot wait to get back into space. Astronaut Paolo Nespoli is on his third space mission.
It's what I call becoming an extraterrestrial person. You know, it's losing your earthling things, and now you are really an extraterrestrial person because you don't think anymore about gravity, you don't think anymore about up or down, you think about what you need to do and position yourself so you can do it in the best way. You need to get used to working, to live first in space, being able to be very confident in the environment where you are. You need to be able to learn to translate extremely efficiently without banging into things. You need to be able to carry stuff. You need to be able to learn how to move around and do things, and how to sleep efficiently, how to work efficiently. And this takes like a month and a half. So after that time, you are fully ready to work. And that's why 6 months, because you have the capability then of performing at 100% of your capabilities, and then, you know, after 6 months, I think people are ready to go back to Earth and, you know, taste again the food, smell the air, see their friends, their family. For me, it was an exhilarating experience. I mean, I found this thing of trying new things. I find it really good. I felt I was like a little kid trying to do something, you know, try to get crazy and get inventive. And sometimes I thought, I should try something like that. And I said, that's not possible. It's never going to work. And then you try it, and you see that it opens up all sorts of other things that you never thought about it. And that it's a very good feeling. I mean, this feeling of discovery. The astronaut in space is one of the resources of the space station, and the control center want them to use as much as possible, so they have to make sure that they can work. In fact, we do work from 7:30 in the morning until 8:30 in the evening. That's the working day, and Houston and the other control center make sure that it's filled with activities. About 50% of that time is used for maintaining the station. We need to fix things, we need to move equipment, we need to change experiment, we need to load and unload spacecraft, we need to prepare for spacewalks. This is an important part. And then another 30 to 40% is actually scientific work. I am an engineer, an aerospace engineer, but I will do experiments that have to do with genetics, with medicine, with life science, with metallurgy. And we have a complex set of experiments spanning 360 degrees.
I think that's an interesting thing.
This one piece will make 52 layers.
Watch on mobile devices or the big screen, all for free. No subscription required.
Which is a sealed environment. I'm going to open up.
It's a little bit going to school, yes. It's a little bit like the adrenaline that pumps in when you are in an exam, and you want to. From one side, you want to show off. You want to show all the things that you know. In the other side, you need to be careful because some of these things can be very tricky, and it's easy to misunderstand something or getting too much involved in one thing and forget about the other one.
There are currently 16 active members of the ESA astronaut corps. Paolo is among the oldest. At 60, this is his third flight into space.
I feel really honored to be able to fly in space again. It's a very nice experience for me. I'm looking forward to use all of this investment that the agency have made in the past year to qualify me, all the personal investment that I made in get qualified and stay qualified and use it again, go to space and be useful. I mean, I'm 60, but I'm going there and I'm expected to perform as anybody else and carry out my task, and I'm looking forward to do what is needed and possibly a little bit more.
Other ESA astronauts who have experienced their first missions in space are already in training for their next. Alexander Gerst has spent 165 days in orbit with 6 hours of EVA experience. Even though he is well aware of the amount of work and effort that lies ahead, he's keen to get back into space.
It's a fantastic feeling to be back in training, of course. You can see the training facilities right behind me, and you can see why it's so interesting. I mean, this is like a full-on mock-up of the space station, so this is really the closest you can get on this planet to how the space station feels and looks like. And I've, of course, missed it a little bit after my last mission. I returned in 2014. That's 3 years ago. So it feels great to be back in that working mode.
He'll certainly be continuing some of the research he started in orbit back in 2014. On top of this, he'll be fulfilling a new role, that of ISS Commander, a job which requires a high level of responsibility for the station and its crew.
Of course, a new part to my training is that on my next mission I have the added responsibility of being the ISS commander, and to me that's a great honor. So I'm very humbled by the trust that people have in me to actually command this fantastic space station. But of course, it comes with a big responsibility also already in training. So it means I'm right now not only responsible for my own training. Like in my last mission, I had to make sure that I'm trained and I can do everything that people need from me in orbit. And now I have a crew to take care of.
Another key element of the returned astronaut's life is to impart their considerable experience in order to help train the next rookie astronauts. Matthias Maurer, ESA's newest astronaut, has been training with astronauts Tim Peake and Luca Parmitano, both of whom boast extensive EVA experience.
It's actually a lot of fun because I can relate what I'm doing on the ground to what I did in orbit, and it gives me perspective to how it's going to be while I train. And as a matter of fact, our feedback to the instructors is very well received because we can improve the training that we receive just by getting our experience into the equation.
It's great to be back in Houston training again. I'll be in the Neutral Buoyancy Laboratory very shortly with Matthias Maurer, the German astronaut, so my ESA colleague. Really looking forward to that as well, trying to sort of impart some of my knowledge from my spacewalk and to share my experience with Matthias. Here in Building 9, of course, it's great to be back, reminiscing about my time on the space station, but also learning about the new developments that are constantly changing on board the space station.
Don't tether to this D-ring on the bottom, that's only for the battery. The other thing too is that you can shove this all the way in here and then on this foot.
I have so many fantastic images and wonderful memories of my 6-month mission to space. If I was to have to choose one highlight, I would probably say the spacewalk was the highlight. Just going out of the hatch and seeing space, seeing Earth, and looking back at the space station from inside a spacesuit, that really was another order of magnitude over and above just the experience of going into space.
You put your toolbox down here, and your toolbox will stay because the water will keep it and the gravity will keep it. In space, you put your toolbox down, you look back, and it's gone, and it's up there, and it's all over the place. So, and all the tools inside your toolbox will all be floating around a lot more. So, the microgravity is really difficult in space.
I was at the NBL earlier this week, and just seeing the suit-up operations and seeing the suited guys going down for their spacewalk training, it really brings into perspective what the realities of a spacewalk are versus the NBL. And you know, there aren't that many. The NBL really is a fantastic place to train for a spacewalk. It's the best place that we can train on Earth.
Crew hook side?
Yes, and actually, this is a good opportunity whenever you're heading out the airlock.
All European astronauts get training on how to operate in a spacesuit, in the American spacesuit. And so we need to learn how the spacesuit works, how it functions, and also how difficult it is to work inside such a suit. It's very limiting, and like a work that takes us 5 minutes here on the ground, in space it takes me half an hour. And afterwards my entire body aches, and it's hard work outside on the station.
And try to do hand over hand. And Matthias, you don't have to ingress the APFR. We could have divers.
I pause for a second to figure out which... I hope that I get the chance to do a spacewalk, because all my colleagues told me a spacewalk, it's like the best experience of your space flight. Leaving the station, seeing the station from the outside, and having a very clear picture of the Earth below you without being limited by a window, just looking through your visor. That is, the perfect image, and I'm really looking forward to it. I'm happy that I'm out of the water and that I actually can move my arms again, how my body is designed to move the arms, because the suit constrains a lot of my arm movement.
We thought it'd be a great idea. It kind of serves its purpose, but we found better techniques like safety tether paths.
When you're in there in that position, and you've got your gravitaddy here, and you got your gravitaddy and everything, just even to see the unlocked lock.
I couldn't see it.
It's good to just have one wire tie dedicated to a bunny ear. And of course you can pop this down, pop that up. Mine is this direction here. I like the joint to be on top because you'll find in the pool you need this to maintain your rigidity.
This right now is in mortar, so in order to do the cal test, you need to either put it in retroclockwise or counterclockwise. There you go. That's a little different. Now you get your LED test, so now you know all your LEDs are working. Don't tether to this D-ring on the bottom. That's only for the battery. The other thing too is that you can shove this all the way in here, and then on this foot. It's not new to you. You know that you're going to go ahead and stick your boot into the toe loop, put your heel down,
and foot in, and then I lean backwards. When we were in orbit, we had 3 spacecraft come up. We had Cygnus, we had HTV, and ATV. ATV was all the way aft, and you have to cross all of the Russian segment in order to transfer cargo to the other side. And you would really need some coordination with our Russian colleagues, because if they're working doing sport, then you're floating in the middle of their activities.
So the station does become a very busy place.
Even in shape, there are modules that are in a different position than compared to when I was up there, and the procedures have changed compared to when I was up there. Specifically the emergency procedures, and all of the payloads are different. So all the training has to be done completely from zero.
The seasoned astronauts still get a kick out of looking to the future, especially when it comes to new equipment and spacecraft like the Orion capsule.
Visiting the Orion capsule today was really exciting. It is the next stage in our space exploration. Europe is very much a firm partner in there. We're providing the service module for the first exploration missions, which is really exciting. Going back to the moon with a vision of using that same vehicle for some form of Mars transportation vehicle.
Currently, we are flying to the ISS, but the ISS program will soon become to an end, or it will become a commercial space station. On the other hand, we are also looking to fly much deeper into space. The ISS flies at 400 kilometers altitude, and with the Orion we can actually go into deep space, for example to the moon, which is 400,000 kilometers, so 1,000 times further away than the ISS. And actually this opens a new perspective into
exploration. We will go to the moon, and after the moon we will go to Mars. And there are lots of adventures, lots of science that we can do in deep space.
Experience isn't the only thing astronauts bring back from space. Their biological specimens help evolve the gastronomical sciences.
Here we are opening the samples we received from Thomas, coming directly from the ISS. There are different samples of urine collected during 10 days of tests.
Providing enough energy for the astronauts is a critical aspect of payload planning, particularly for long-duration flights.
The centre will provide us with an inventory of all the food taken by Thomas up there for all the time of the exercises he made during the 10 days of our tests. Here, for example, we can see on this table the energy consumption of Thomas every day, how much he has spent.
You can't order pizza to go in orbit, so the decisions about what to take with them can be critical for astronauts.
Food is something that's really underestimated down here on the ground. Like, people go like, oh yeah, I'm gonna fly to space, I don't care what food I take. It's not bad. Well, you start caring about that 1 month into the mission, and then if you made the wrong decisions, it's a hard remaining 5 months. This is mainly to trigger my memory for the food that I already had, and now I can make the choices based on how I remember them. And then there's a few new ones in between. For them, I have to sort of guess. There's still debate if the taste actually changes the actual taste buds, if people perceive taste differently. My personal opinion is we don't. I think it's the same, but the cravings change, and that is really hard to predict. Right now, I might not care so much for broccoli and cauliflower, but up there, I really liked it. Because it's pretty protein loaded. What we have a lot of meat, and then I tried to add anything that reminds me of something green. Let's put it that way. I mean, those beans, they don't resemble beans a lot, but they actually taste really nice. Oh, we didn't have blueberries last time, right? We had raisins. That stuff is awesome. Last time I got a few Russian bonus containers. They also have very, very good food. Their food is more succulent, like they have more grease in there, also more spices, also more salt, which is not so good for the bones. So I tried not to eat so much of it. The American food or the European food is more healthy, I would say. But once in a while, it's really satisfying to just open a can of this really succulent, savory Russian food, and I absolutely enjoyed it. It's really good. On my last expedition, we tried to have the meals all together. The US crew, European crew together, we always had meals together when we could. And then on the weekends, we would gather, like the 6 of us. Either the Russians would invite us to their segment, or we would invite them. And then we have the big table, and everybody brings something together, and it's kind of this medley. That's important. Those are the relaxation moments. You can take a time, you put music on, and you chat about how your week went. And it's the last thing that I have for today, after a successful tasting of 48 items.
With experience comes cooperation. ESA is now conducting astronaut training activities in China. Samantha Cristoforetti and Ruki Matthias were each teamed with 2 taikonauts, who between them have considerable spaceflight experience.
We are basically practicing what would happen if there was an off-nominal landing. We wouldn't land on the ground, but we would actually land in the water, and we would have to survive independently for some time, and using the rescue boats and the rescue equipments, and exiting, of course, the re-entry capsule autonomously.
After donning insulation and buoyancy suits, they practiced rescue procedures with both a ship and a helicopter from a mock-up Shenzhou capsule. Space missions can be unpredictable, and training exercises such as these ensure that astronauts are prepared for every eventuality.
The training experience so far is great. The Chinese are really well prepared. It's a high-level equipment. We get helicopter airlifting. We have a huge sea survival rescue ship, which is usually employed on the high seas. So very good equipment and a very good experience so far.
Accompanying Samantha and Matthias in China were an ESA flight surgeon and a training specialist who gained insights into the different cultural nuances and approaches.
During this training, I have had the opportunity to work very closely with our Chinese medical colleagues, and I'm very, very impressed about how they have combined their traditional Chinese medicine, which has thousands of years of history, with the most advanced medical knowledge that we can find now in the world.
Training here is very, very well organized. So we have different ways of approaching training, which is inherited from the ISS program, but actually they are not that far away. So it means that we find common words and common understanding in the way they also organize this training. So for us, it's a very good sign for further cooperation with the Chinese.
This training exercise wasn't the first collaboration between the two space agencies. In July 2016, Chinese astronaut Ye Guangfu joined ESA's caving course in Sardinia to experience an extreme environment as part of a multicultural crew. Both activities stem from the 2015 agreement to boost collaboration between ESA and the China Manned Space Agency, with the ultimate goal of flying European astronauts on board the Chinese space station from 2022.
This joint training we are doing here is a first step in a cooperation that we all hope will lead one day in the early 2020s to a European astronaut flying with the taikonauts to the future Chinese space station. So of course I would be thrilled if I had that opportunity.
Organized by the Astronaut Center of China in cooperation with the Ministry of Transport's Beihai Rescue Bureau, this training session has been an important step towards long-term collaboration. Space flight opens up new horizons, not just for astronauts, but for nations as well.
So as you know, my last mission was called the Blue Dot. We focused on the view back, the perspective back from space onto our little planet Earth as it flies through the black universe. Now, on the new mission, we decided to take a step further, to even view with a bigger perspective, to acknowledge that it's not only about our little blue planet Earth, but that there's much more out there in the universe. And as the early explorers who sailed, beyond the horizon, towards the horizon, and even further, we named our new mission the Horizons Mission.
The tenuous envelope of gas surrounding our planet is an unbelievably complex machine that protects us from the vacuum of space, shelters us from harmful radiation, and allows us and the biosphere to breathe. It is our atmosphere, and we need to learn much more about it so we can take better care of it. Soon, the European Space Agency ESA will launch its new Earth observation satellite called Aeolus. Using cutting-edge laser technology, Aeolus will provide near real-time observations of wind profiles across the globe, These will improve the accuracy of numerical weather prediction and climate modeling and advance our understanding of global atmospheric dynamics.
Aeolus is one of the Earth explorers that is going to look at the Earth, trying to understand the wind profiles globally. And that's a first, it doesn't exist yet. The whole idea was that we only have wind measurements on very different small spots on the Earth, and we didn't have it globally. So the mission scientists have been asking for this because it's a gap in our measurement system.
The mission aims to expand our knowledge of our atmosphere and weather systems. Aeolus will achieve this by providing global observations of wind profiles from space, providing data which has never been available before.
It's unknown ground. It's what we call uncharted territory. So we are the first agency trying to get a satellite in orbit that looks at the Earth with a laser and trying to understand the wind profile, so the direction, the height and the wind speed. And therefore improving the weather forecast. Because nowadays we only have at single points balloons that measure the wind, or airplanes that give us some data, or at fixed points, at discrete points. This will look down to the Earth in a polar orbit, will dump every 90 minutes the data to Svalbard. That will be distributed to all the European meteorological institutes. And then when you're sitting at home on your couch, you watch the television and you see a weather forecast that is much better than we have it today.
Aeolus will fly in a sun-synchronized polar orbit 320 kilometers above Earth's surface. Its data will be sent to ESA's Svalbard ground station, located in the archipelago halfway between Norway and the North Pole, every 90 minutes. The satellite's main instrument is Aladdin.
Yes, the way the Aladdin instrument works is to eject an ultraviolet beam down through the atmosphere, and then particles of moisture in the atmosphere at various levels are in motion because of the wind, and the system measures the backscatter from those particles using the Doppler effect and can detect the wind speed at the various altitudes, and that's the way the system operates.
The development of Aeolus has been a long and difficult process, with new and cutting-edge technologies designed, developed and tested on the ground.
It has been a very difficult challenge, let's say. It's a long life because it exists already for 16 years, the program. And when we first had the part of the instrument, when we switched it on, it worked. Then we put it in vacuum and it stopped working. And no one had realized that we needed oxygen inside the satellite to keep the laser active. So it was quite a challenge, so we had to develop a whole new set of techniques. It's maybe a bit too detailed to go in all the details, but as a lot of technology has been developed to put in this nice little satellite which is behind me.
Aeolus is another ESA Earth Explorer mission aimed at pioneering new technology while providing useful data about our ecosystem. It showcases the technological expertise of the European space industry and ESA's objective of monitoring and understanding the planet we all live on.
The main challenge for us has been within the development of the Aladdin instrument. There's a very high-powered ultraviolet laser system in there that is an inherent part of the instrument. And the technology behind that laser system, the development of a stable laser, high-powered laser beam, and the optics that then focus and divert that beam through the system is very critical, and that's been a very key part of the development. After many years and much hard work across the European industry, we've overcome those problems. We've got some new development and through coating technology on the optical surfaces to protect them. And we've now got a stable system that's been fully tested on the ground, and we're ready to go.
The tracking of air pollution is also part of the European Union's Earth observation program, Copernicus. One of the satellites that gave scientists massive amounts of data on atmospheric pollution was Envisat. This satellite used several spectrometers to detect ozone and trace gases in our atmosphere. The latest satellite, the Sentinel-5 precursor mission, was recently launched and builds on that legacy of Envisat.
So we started this precursor mission because the scientists wanted continuity of data. At the moment, we only have one spacecraft doing that job for us, which is OMI, and OMI is coming towards the end of its lifetime. The next missions that will do this job is Sentinel-4 on Metopsate generation, which will only be launched in early 20s. In the meantime, to ensure a continuity of data, we need Sentinel-5 precursor. It will be the only such mission doing this job until then.
Sentinel-5B is a precursor to the Sentinel-5 mission, which should be launched around 2021. But it's not only a precursor, it's also a gap filler, because it's filling the gap based on the data that we have coming from GOMES, Kirmaki and OMI measurements towards this future Sentinel-4 and Sentinel-5 missions.
Sentinel-5P is the first atmospheric chemistry mission within Copernicus. Its main instrument is a state-of-the-art spectrometer called TROPOME, which will be used to detect trace gases in our atmosphere. The Sentinel-5P satellite is a timely replacement for the ERS and Envisat after it stopped working. There was an urgent need to fill the gap in observing air quality and air pollution. Furthermore, according to the World Health Organization, air pollution is responsible for over 3.7 million premature deaths worldwide every year. But the health costs are even greater, as many people suffer from non-lethal afflictions either caused or aggravated by breathing polluted air. Another major health concern on which Sentinel-5P is gathering data is the ozone in our atmosphere. When that ozone is depleted, ultraviolet light from the sun is no longer filtered. Increased exposure to UV light can cause skin cancer, immune system damage, and other ailments in humans.
The TROPOME data will be used operationally, so it will be used to improve the air quality forecasts. And air quality forecasts are of course important for people who are vulnerable to pollution. But also for the general public in case of big smog events. What we can do with the TROPOME data is we can look at the emissions of pollutants, and when you see them changing over time, that is very important because we can see if certain policy measures have the right impact or where we see still increases and still have to do more to reduce the polluting emissions.
A decline in air quality such as smog poses massive risks for people's health. And one of the main contributors to climate change is the pollution of our atmosphere by greenhouse gases such as CO2 and methane. This is why measurements on air pollution need to be undertaken everywhere. Like here, for instance, with a mobile measurement station at the University of Bremen. It detects smog and industrial emissions. These local measurements supplement and validate the global observations from satellites, which in turn are needed for scientists to study the air we breathe and the planet we live on.
Well, the satellites are a key information base and knowledge base for the study of atmospheric physics, chemistry and meteorology. It's essential data because we need to know not just what's coming out at a given place, but we need to know where it's going, where it's depositing at the surface, how it's being transformed, is it going to be taken up by clouds and rained out, if so, where? And this whole transport and transformation process is a complex business. In general, we have this problem of unambiguously identifying anthropogenic impact from natural phenomena or natural behavior in this complex system and how we're modifying it. So this is the challenge for the science, which is a necessary prerequisite to enable good legislation and ultimately sustainable development. So in this context, measurements from space are essential because they provide us with the global picture or from the local to the global scale.
The Sentinel-5P mission will have quite some improvements as compared to previous missions. For example, if you look at the spatial resolution, we will break a record, namely we will look at city scale because the Nadia pixel size will be as low as 3.5 kilometers times 7 kilometers. So we can then investigate small-scale features over big cities and city agglomerates, for example.
The mission will monitor the atmosphere using the TROPOME spectrometer to monitor various trace gases in our atmosphere and reduce data gaps between ENVISAT and Sentinel-5. By combining satellite data with the local measurements on the ground, scientists can properly monitor air pollution and how it impacts us and our planet.
We have lots to understand to assess the impact. Ultimately, more pollution is bad for health, bad for people, and the estimates are somewhere between 3 and 7 million people a year die prematurely from air pollution. This is a large number of people.
At the forefront of Earth observation, the European Space Agency helps us to understand climate change and pollution by giving scientists and policymakers the data that can drive legislation.
These atmospheric measurements are extremely important for mankind. First of all, to see how our planet changes in terms of climate, but also to see how air quality changes in different places and over time. We have highly polluted areas, which are, of course, transporting pollution from one place to the other. So these fluxes of pollution or gases is very important to monitor. But also, if you take Europe, for example, Europe has introduced very strong legislation and regulations in order to reduce greenhouse gas emissions. And this has also to be verified, and these satellites are a very good measure or very good way of making sure that these reductions are taking place at a large scale.
In the early 2020s, the space component of the Copernicus atmospheric services will be extended through the addition of Sentinel-4 and 5 missions. Sentinel-4 will be a geostationary mission, whereas Sentinel-5 will be a low polar orbiting mission like Sentinel-5P. Atmospheric services are part of the Copernicus portfolio, which comprises 6 main themes: marine, land, emergency, security, climate, and atmosphere, giving a complete overview of our planet's health and its evolutions.
Can have a lot of practical applications using the data from the Sentinel-5P mission. One idea would be perhaps if we look at the harmful UV radiation, you could set up UV radiation services so that people on the street, so to speak, in the sun like today, could inform themselves how harmful it is to receive this short-wave ultraviolet radiation.
The Sentinel-5 precursor data will be combined with models and other data to develop targeted services, and they will be available as apps, social media information, or web services, so that a lot of people can choose their way they want to be informed about the environment.
Atmospheric measurements are important because especially these measurements that are done by Sentinel-5 precursor, like tropospheric ozone, information about nitrogen dioxide, sulfur dioxide, also information about aerosols, particulate matter. They have impact on the health of people. They can impact the people who have problems with their hearts or with their lungs. And as it has been shown, there are more than 400,000 premature deaths in the European commissioning based on exposure to air pollution.
Air quality in Europe in particular, but also in the US and in Japan, got much better over the last years. That's a really big improvement. And at the same time, air quality in the developing countries, in particular in Asia, has gotten worse because they use much more energy nowadays, and that's a big source of air pollution. Also, if they are using more cars, that will pollute the air more. So it's different, depends on where you live. In some places air quality gets better, in other places air quality gets worse. I should add that in the last 3 years, air quality in China has improved because they are very ambitious about that and have very strict rules. So they are trying to follow the European or United States path in improving air quality with better technology.
Observation from space is just one of several methods of measuring atmospheric pollution. Satellites provide the data, although they need to be calibrated with measurements on the ground.
So we are offering a comprehensive analysis, integrating data at different scales. So we are using observations, we are combined with modeling, with satellite data, and all this information is complementing each other. This is the good thing of this kind of analysis. Satellite have the advantage of providing a global picture. Trends, you can study trends very well, how the main flows are taking place. But satellite data, they don't have the resolution to get in detail in the individual processes. So here, with our in situ measurements, we are getting in one particular point, and we get deeply in the detail.
The satellite gives these beautiful maps, but you can only use them really if you have a validation measurement to compare to, and this needs to be a very good measurement, and this needs to be taken on the ground. That's very important for us because we need to be very confident of the satellite data. And once you have launched a satellite, it's out of your hands, and you cannot bring it to the lab and double check and test it. It's there, and you need to trust the data, and the only way to get this confidence in the data is by comparison to other measurements.
Other forms of atmospheric pollution, such as the exhausting of carbon dioxide, methane and ozone, contribute greatly to climate change.
Well, I think basically it's often the case that our models, which are extremely complex and good tools, often don't necessarily have the right physics or chemistry in them to be able to predict what's going on in the future. So a lot of the time in atmospheric science, we've been making discoveries. Back in the late 19th century, early 20th century, the discovery of the stratosphere was a complete surprise at the time, or fairly surprising. The fact that temperature increases above the tropopause. This was a surprising discovery, and really that's been typical. We didn't expect summer smog. We don't understand why in Paris there was a really big smog a couple of years ago in spite of improvements of legislation. This winter we had in London a smog which is maybe being attributed to excessive wood burning recently. So there's a lot of things although we're getting over the last 25 years much better information, but the satellites in particular tell us ultimately, or could tell us ultimately, what the source strengths are and enable us to follow the information, and thereby, together with models, give really good prediction for people about the air quality that they're receiving.
The Copernicus program is very important for Europe and for the world. First of all, the Copernicus program is providing free data to everyone at any place in the world. So many users, not only in Europe, but also in America, in Asia, are using our data in a very large scale and very significantly. So therefore, Copernicus is really monitoring the health of our planet from all dimensions: the atmosphere, the oceans, the land surface, the ice caps, and this whole system of the Earth composed of these components is monitored constantly with Copernicus. And therefore it is really important to see what is the state of our planet and how it will evolve in the future.
Well, the data can be used for different applications. So, for example, for the air quality forecasts, it's also used by KNMI, for example, for the UV forecasts. And we also use it to warn the aviation for volcanic ash plumes. On top of that, the data will also be used by scientists around the world to study the atmosphere and to study how man is changing the atmosphere over time. Continuous monitoring is very important, especially when you're looking at slow changes, and an overlap between the data is then really necessary to be able to glue these different data sets together to one data record. And we have data records from these kind of instruments starting in the 19s, for example, for the pollution. It's very important to maintain these valuable data records and to extend them into the future.
Well, the data is important for our climate research and also for our environment, because the air we breathe, it could be changed due to all sorts of pollution events. And then a second example is that we need to monitor our ozone layer. Since ozone is destroyed due to chlorofluorocarbons, Sentinel-5P will have also the role to monitor the further evolution of the ozone layer.
Mankind can halt the pollution of our atmosphere with good legislation. The European Space Agency, ESA, works tirelessly to monitor our planet and the air we breathe.
We need a future where we, with so many people on the Earth, are in a position to maintain a good quality of living for human beings, but also for the biosphere.